Come back once again. My name is Victor Dugomo here, and in this part of our discussion on trigonometry, we are going to be delving into elevations and depressions. Elevations and depressions. Okay, it is still around problems of triangles. Okay, and then, but I want to take us to you know, a little outing, okay, for you to see what we mean when we say that this is an elevated height. I'm trusting God that you are going to enjoy this outing. So just follow me. So, my students, um, we wanted to make what we are discussing about elevation and elevation much real and practical. So, this is a hill. This is a hill. You can see it. Okay, you can see this hill. It's very huge. It's very huge. I am believing that the camera can be able to capture it clearly. The hill is very huge. I I don't even know if I can be able to climb this one. You know, it's very huge. Okay, so we tried to see if we can be able to. When you say an elevation, you should be able to understand what an elevation is. I'm trying to see if I can find any direction, you know, and if I can be able to find a way of climbing to some extent. I don't think if I can be able to climb this hill. It's very huge. Okay, I think it's very huge. Let me see what I can do. Okay, it seems that there is a path here one can follow. See, look at the bird up there. Can you see that bird? Oh, it's flying away. It's flying away. So when you say a man at the base of a a cliff, look at where I was coming from, observes the angle of elevation of the top of a hill. Okay, you can see that, the elevation, the top of this hill should be somewhere up there, very up there, very up there. Okay, so it's not quite easy climbing this one. It's very mountainous. It's very huge. But let me see what I can do. Let me see if I can, you know, somebody is coming up there. So those people told me that it's this way to the top. Let me see if I can be able to make it to the top of this hill. Let me see if I can be able to make it to the top of this hill. Okay, there's a path here one needs to follow. It's angle of elevation and depression I want to introduce to us, and we want to make it real life. You might be asking me, why do you choose to take this type of risk? So if you were able to understand what this is all about and how it applies to this topic, I think it was it. Yeah. See, taking my tour around this hill is very huge. Very huge. Nsukka has a lot of them. Nsukka has a lot of them. You can imagine I'm still going. I'm still going. This is almost like taking the perimeter of this place. This is somewhat a very big place. A very big place. There's somebody at the front there. This is the side of it from another side. I don't know if I can be able to climb this. Let me see if I can try, even if it is going to some extent. So, my students, I am sure that this is what we call an elevation. This is what we call an elevation. This is quite huge. I, I'm afraid if I have, you know, this is quite huge. Somebody like me, somebody like me that has phobia for height, I don't think if I can be able to make it to the top, but I'm sure that you've been able to capture the explanation I want to give, as it has to do with an elevation, an elevation, an elevated height. So this is it. This is it. Is is a is a hill. This is a hill. Okay. This is a hill. It's very very huge. Look at the top of that hill. Look at the top of that hill from where I am now. You can see I have even taken some steps up. Okay, you can still see the distance I took to climb to the top where I am now, but I can't be able to take it to the that up there. Okay, because I don't have some equipment that can help me to be able to ascend to that top. But this is a hill. Okay, it's just my intention to make the class to be more realistic, as it has to do with an elevation. When you say an elevation, okay, you can be able to understand what an elevation is, and when you say a depression, you can be able to understand what a depression is. Okay, so down there is the base of this cliff, okay, of this hill, and then up there you can see up there is the top, very very high. This is very very high. Okay, it's a very very high elevation. So thank you for this outing. I will be taking my way back right now. All right. Introduction to what we want to look at in elevation and depression. Okay. Now you followed me around that hill. It wasn't a funny. I couldn't have the equipment to climb that. The top of that hill is very very steep. It's very very steep, so I couldn't be able to climb up. Look at a typical demonstration of what I wanted to show you in that outing. Can you see this is a hill? Okay, it's a typical of what that outing is. You see the hill, you see the top of the hill, you see this is the vertical line that connects the base. Okay, so one can be able to calculate this if you can be able to use a clinometer to measure the angle of elevation to the top of that hill. This is the horizontal ground, and this is like me, the observer of the top. Okay, the observer of the top of that hill. So if we're able to get something that is like in this question that says the angle of elevation of the top of a hill, like this is a typical question that you can face as a challenge in angles of elevation and depression. The angle of elevation of the top of a hill 42 meters away from its base on the horizontal ground is 36 degrees. We have the angle of elevation has been measured. Okay, you say find the height of the hill. It's just a very typical question on angles of elevation and depression, and one can quickly put up a diagram to illustrate what that is all about, and then following the calculation in it. Okay, so if I have something like this now to be the height of the hill, and then this the horizontal ground, and then you have something like this, you have something like that. Okay, so you can be able to put up these informations that are made available here. You say the angle of elevation to the top of the hill 42 meters away from its base. So if this is the base of the hill, let me label it kappa B, and this is 42 meters. Okay, and then this angle here is given to us to be 36 degrees, and then let's call here A, the top of the hill sort of, and then somewhere here let's call it C, and then they say calculate the height of this hill. So you can see that let's call it H, the height of this hill. Okay, let's call it H, and one can begin to reason the procedures that are available to us in doing calculations around problems of triangles. Okay, you can use Pythagoras theorem when you have, though I'm still going to elaborate on that, a right angle triangle and you're calculating the sides. And you can use what we call SOHCAHTOA when you have a right angle triangle and possibly calculating there is presence of an angle in it, like in this question now. And then you can use sine rule. That sine rule and cosine rule, we have done a lot of work in there. We have done a lot of, we're able to derive the sine rule and we're able to derive the cosine rule. All these, problems, all these procedures is what we use in solving problems of triangles. And I know if you check out on those and on that those classes, you'll be able to enjoy them really, and you're able to follow up what we are doing in the now. All right, so I can be able to do this calculation now and say solving for h using um SOHCAHTOA. Okay, because what I want is this, and possibly what I'm going to, because if you look at this place, you see the opposite is available and the adjacent side is also available in relation to this angle. So this the ratio of the opposite side and the adjacent side will give us, look at it here, the opposite side and the adjacent side, that's the tangent of that angle. So we are going to say tan 36 degrees is equals to h over 42. Okay, it's a very simple thing to do. So we can now subject this h and have h equals to, when we do cross multiplication, we'll be able to obtain 42 tan 36 degrees, and then our h will be equals to, we take the tangent of that angle there, 36 degrees, 36, okay, that's 0.7265. 42 times 0.726, if I hope I'm correct, 0.7265. One just need to be more careful here to maintain high level of accuracy. Okay, so we have V times 42 times 42 equals to 30.5. So H is equal to 30.5 units of measurement meters. Okay, so you can see that this is, there are several ways to explain, and trust me, we are still bringing up more examples to illustrate this. You understand that we are still bringing more examples. We are still working, is under trigonometry, we are still working on issues that has to do with triangles, and then angles of elevation and depression is there. And after this, angles of elevation and depression will be going down to bearing and distances. And I'm trusting God you will not need those classes. Please like what we are doing, share it, and subscribe to the channel so that you can be able to follow all that we are doing. As you do that, you won't regret. Thank you.